Have you ever stopped to think if the AI you're using is actually secure? I mean, we interact with these super polished, really helpful digital assistants every day. But, underneath that friendly face, there's a huge, often overlooked security problem. So let's get into it because what we're about to unpack is a fundamental challenge right at the heart of the AI systems we all rely on. Okay, let's start with just one number 100%. It's a stark number. And honestly, it should be. Because this number, it represents a massive vulnerability in our most advanced AI systems. So, what in the world does that mean? Well, it means that in a recent, huge red teaming competition, 100% of the leading AI agents, we're talking from the big labs like OpenAI, Anthropic, and Google DeepMind, could be successfully attacked. I mean, they were getting unauthorized access to data and completely breaking their own safety rules. Not a single one held up. So the big question is, why? Why are even the best of the best so fragile?
Well, to really get it, you have to understand that every advanced AI model basically has two different personalities. Yeah, two. There's the one you talk to, the one you see, and then there's the one that's working underneath it all. And this dual nature, it's the absolute key to understanding this whole security problem.
So first up, let's meet what I like to call the raw brain of the operation. This is the base model. Just think of it as the incredibly powerful, completely unfiltered, and kind of untamed core of the AI. You see, the base model is what you get after that first huge training phase on just enormous amounts of data. It's ridiculously capable for sure, but it hasn't been taught to be helpful or harmless or even how to follow your instructions. It just knows a ton of information and patterns, but with absolutely zero guardrails. Okay, so if you look at the threat profile here, it tells a pretty clear story. If an attacker manages to get their hands on the model's raw files, its weights, which is basically its core programming, they're dealing with a system with no safety features at all. And check out effective attacks. They don't need any clever tricks. They can just ask it directly for harmful stuff. Now, testing this version is super important for finding those raw foundational problems, but it's not what the average person is up against, because this isn't the version we usually interact with. All right, so that's the raw brain. Now let's talk about the other personality, the one you actually know. This is the polished instruction-following model. This is the AI's public face.
Right, so this is the base model after it's been sent to finishing school, basically. It's been fine-tuned to be a helpful conversationalist. It's been specifically trained to say no to dangerous requests and to follow all the safety guidelines. This is the version you're using in apps like ChatGPT or Claude.
And this table right here, it shows how the game totally changes. The threat model is different now. The AI has logic to refuse bad requests. But, and this is a big but, it's also trained to be really obedient. And attackers are clever. They use these sophisticated tricks you see under effective attacks. Things like jailbreaks, which are these crafty prompts that trick the AI into ignoring its safety rules. Or prompt injections, where they hide malicious instructions inside something that looks totally innocent. Testing for this stuff shows you the real-world risks people are actually facing. So you've got the raw brain and the polite public face. It seems like the solution is obvious, right? Just make the public face stronger. Well, not exactly. This is where things get really interesting. See, the very process designed to make an AI better can sometimes, accidentally, make it a lot less safe. So a lot of companies will take a safe, already aligned model, and then they'll fine-tune it even more for a specific job, like, say, being a cybersecurity assistant. The goal is to make it smarter and more useful in that one area. But this process can have a really dangerous and totally unintended side effect. And this quote from Encrypt AI's research just hits the nail on the head. They took a safe model, fine-tuned it on specialized security info, and found something pretty alarming. The process of teaching it to be a better security analyst had unintentionally erased its original safety training. The new knowledge literally overwrote the old rules. So here's how it all goes down. Step 1. You start with a model that already has its safety guardrails up. It knows what not to do. Step 2. You fine-tune it with a new specialized set of data. And here's the crazy part. Even if that new data is totally safe and harmless, the tuning process itself can cause the model to just forget. It overwrites its foundational safety rules, leaving it vulnerable in ways it never was before. So if making a model better can actually break its safety features, what on earth is the solution? Well, you have to test the entire system, not just the shiny, finished part. You have to red team the whole AI, which just means you intentionally attack it, trying to find all its weaknesses before the bad guys do. And this is the most important takeaway. You can't just test the polished final product and call it a day. That's kind of like testing if a bank's tellers are polite, but never bothering to check if the vault door is actually locked. Real security demands a dual approach. You have to test both the raw-best model and the public-facing Instruct-Tuned model. This table really lays it all out, nice and simple. Take a look at the row for test alignment. You'll see a check mark for the Instruct model test because that's the one with safety alignment, but a big X for the base model because it doesn't have any alignment to test in the first place. On the flip side, to surface raw harms, the base model test is absolutely essential, whereas the Instruct model might hide those problems behind its filters. Each test finds a different, critical type of weakness. You need both to see the whole picture. Look, if you want to boil it all down to one simple idea, it's this. Testing the base model shows you what the model is truly capable of, what it can do at its core. And testing the Instruct model shows you how good your safety measures are at stopping it, how well it's prevented from doing it. You absolutely have to know both. So all of this brings us to the final and most critical question. In this world of AI that's changing by the second, security isn't some one-time checkmark. It's a constant process. The real challenge isn't just asking, is my model safe right now? It's building a system to make sure you can keep it safe as it learns, adapts, and gets fine-tuned for whatever comes next.